So now we can have the last topic on the quantum theory of scattering. It's called the optical theorem. Okay, now in partial wave analysis, we have found the expression for total scattering cross section sigma, which is given as 4 pi upon k square sum over L to L plus 1 sine square of delta L. Okay, now what is the expression for the scattering amplitude? So if you look at the expression for scattering amplitude, which is denoted as f of theta, it is again 1 upon k sum over L to L plus 1 PL of cos theta e raised to I delta L, the sine of delta L. Okay. Now, what happens? The scattering amplitude at theta equal to 0. So theta equal to 0 is nothing but the incident wave direction. So what would be the scattering amplitude along the direction of incident wave? So the scattering amplitude along the direction of incident wave f of theta, sorry, f of 0 is 1 upon k sum over L to L plus 1. It become PL of cos 1, that will cos 0. The cos 0 is 1, so PL of 1 is simply become 1. Then e raised to I delta L sine of delta L. So e raised to I delta L, we can write cos of delta L plus I sine of delta L times the sine of delta L. Okay, so we have two parts here. The real part has a product of cos delta L times sine delta L, and we have imaginary part which is sine square delta L. So what would be the imaginary part of f of 0, the scattering amplitude along the direction? So it is 1 upon k sum over L to L plus 1 sine square of delta L. Now if you look at your first expression and the last expression, we can connect. Okay, I can write my sigma as 4 pi times the imaginary part of f of 0. Okay, so there is a k square here only k, so there should be 4 pi upon k times imaginary part of f of 0. Now this equation is known as the optical theorem. Okay, so this is basically a theorem. So we are very surprised to see this kind of very simple theorem, and I will discuss what is the importance of it. Okay, so this optical theorem states that the total scattering cross section is simply the 4 pi by k times of the imaginary part of scattering amplitude along the direction of incident wave. Okay, so this f of 0 will usually call it as a forward scattering amplitude. So on words, I can say the optical theorem is the total cross section is 4 pi by k times of imaginary part of forward scattering amplitude. Okay, so what is the importance of this theorem? So this theorem states that the information of total scattering cross section is well within the information of forward scattering amplitude. So that means whenever a particle scattering through interaction, then some of the particle will just pass through the target without any interaction. Okay, so that means the information of uh, the the scattering particle would be available from the information of the data of unscattered particle. Okay, so what happens is if you know that what is the total number of incident particle that you incident on the target, and if you know about how much particle are not scattered, then from that information you will come to know how many particles were originally scattered in the interaction. So that is the physical basis of this optical theorem. That is the information of the scattering is available within the data of the information of unscattered particle, not scattered particle or the forward scattering particle. Okay. So with that remarks, I think it is the time to uh, close this discussion of quantum theory of scattering, and we have discussed only the the very basics of the scattering theory, and we don't have much time to discuss some problems. And if you have time, please go through the problems in the textbook. There are certain solved problems in your textbooks, and it will be helpful to understand the concept very much. Okay, so thank you everyone for watching this video lectures, and hopefully the next term we'll have a discussion through offline mode. Okay, so we can have much discussion directly. Okay, so thanks again. We'll see you later.